Hello everyone, welcome to another video in my channel. Before me is a very interesting mathematical problem. We have 3x minus x cubed all over 1 minus 3x squared is equal to root 3. When we look at the right hand side of the problem, we'll see that it is an irrational number, and the left hand side is probably a rational number. So we have a problem where a rational number is equated to an irrational number. How can we solve this problem? One way we can solve it is by squaring both sides. If we do that, we'll be able to successfully eliminate the square root sign and then be able to expand the left hand side. However, when we expand the left hand side, we will run into a problem because we are going to get a term such as x to the power 6, which is the term with the highest power of the polynomial. So what are we going to do to solve this problem and also not to run into problem, since we want to avoid tedium in solving mathematics? If we look at these parts, we will see that it is a value in trigonometry. If, for example, I have an equilateral triangle of sides 2 units, since it is an equilateral triangle, this side is, the angle here is 60 degrees, and this is also 60 degrees, and this is 60 degrees. Let me now draw a bisector, and this bisector would cut this angle into 2 equal parts. This is 30 degrees, and this is 1, and this is 1. Let's call here A, here B, and here C, and this middle term be M. Now, what we need to do is to find this part of the triangle. And we are going to use Pythagoras theorem. That is, the hypotenuse squared, that is this side, is equal to this side 1 squared plus this side, which is MB squared. Now, if we are considering 60 degree, here becomes the opposite. If 30 is the angle we are considering, here becomes the opposite. So, finishing up, we have 4 minus 1 is equal to MB squared. And so, side MB is equal to root 3. So here is our root 3, the root 3 we are looking for. Let us notice that it is the opposite side to 60 degrees. So tan 60 degrees here is equal to root 3 over 1, which is our root 3. So that means I can convert this part to a trig function, and then the equation becomes a trigonometric equation. But how are we going to proceed? First, let's remember we are asked to find all the values of x. That simply means that tan 60 degrees is root 3. Also, if I add 180 to 60, that is tan 180 plus 60, which is 240, I will have root 3. Also, if I add 180 to this one, that is tan 360 plus 60, that is tan 420, I will also have root 3. More like, I'll have tan theta equals to 60 degrees here, then 240 degrees, 420 degrees, and so forth. That is 60 plus 180 times n in degrees. That is what our tan theta is. Remember, tan theta is tan 60. I can convert this one to radians. These are in degrees. So tan theta can also be written in radians as pi over 3 plus 180 is pi times n, where n is 0, 1, 2, 3, and so forth. That simply means that I'm going to equate this thing to tan theta, and then tan theta is equal to x. So my tan theta is equal to x, and then x is root 3. And then x is root 3. And then root 3 can give us all these values in both radians and in degrees. Now, why do I equate tan theta to x? I'm going to do this expansion. If I have tan theta plus phi, it will expand into tan theta plus tan phi over 1 minus tan theta tan phi. Now, if I replace this phi with theta, that is tan 2 theta, theta plus theta, 2 theta, I will have tan theta plus tan theta, that is 2 tan theta, all over 1 minus tan theta times tan theta, that is tan square theta. If I substitute tan theta for x here, I will not get this expression. Now, if I also add theta to this, that is tan theta, tan 2 theta rather, plus theta, I will have tan theta, that is tan 2 theta first, plus tan theta, all over 1 minus tan 2 theta times tan theta. Now replacing this for tan 2 theta, I have 2 tan theta over 1 minus tan square theta plus tan theta here, all over 1 minus, that is this tan 2 theta is this part, giving us 2 tan theta, all over 1 minus tan square theta times tan theta. If I simplify everything, I'll have this. I'll take the LCM of this fraction and this fraction, which is 1 minus tan square theta. Now, 1 minus tan square theta divided by this will give us 2 tan theta, plus this divided by 1 will give us tan theta times 1 minus tan square theta, all over. Now the LCM again is 1 minus tan square theta. This divided by this will give us this, that is 2 tan square theta, then minus this divided by 1 will give us this, which is 1 minus tan square theta. Good. Let us remember this is tan 3 theta. So it simply means that I can divide these two together. This will cancel this, remaining 2 tan theta. If I open this bracket, I have tan theta added to this one, that is 3 tan theta, then minus tan theta times tan square theta will give us tan 3 theta, all over. This is 1, then I'll add these two together, giving us minus 3 tan square theta. Let us remember that tan theta is equal to x. So if we replace x here, I will have 3x minus x cubed over 1 minus 3x squared, which is our root 3. That simply means that tan theta is x. And if that's the case, our x equals to tan 60, as we have seen here, or x equals to tan 240, or x equals to tan 480. Now, collecting them together, we are asked to find all the values of x. It simply means that x is equal to pi over 3 plus pi n, where n is 1, 2, 3, and so forth. Please like this video if you find it interesting. Subscribe to my channel if you haven't done so, and also share this video. I would like to read your comments in the comment section. Thanks for watching, and see you in another video. Bye.